part to any experiment is ensuring everybody in your lab group are wearing proper lab attire. Additionally, you want to ensure any chemical that you're using is poured from the stock container into a secondary glass container. The next step is to draw the stock solution into the graduated pipette and taking the initial value by looking at the meniscus of the stock solution within the graduated pipette. As you can see, the measurement should be taken at eye level to get the most accurate reading, again looking at the meniscus. The next step is to pipette the stock solution into the 25 milliliter cylinder. After pipetting the solution, you'll record the secondary value and use it to calculate the amount of stock solution that you put in the beaker by subtracting the initial by the secondary and taking the absolute value of that. And of course, don't forget to write down this number as you'll need it later. The next step is to dilute the stock solution by following the same pipetting procedures to take the water from the graduated cylinder and place it into the 25 milliliter flask up until the point where it reaches the 25 milliliter line. Again, you can see you want to measure up the bottom of the meniscus with the 25 milliliter line in the flask. After finding the mass of your new diluted solution, you can find the concentration using the formula C1 times M1 equals C2 times M2. We repeated this process 4 more times in order to establish our data set. The way you can identify the relation between the solutions is the stock solution has a known concentration and volume once put in, and then once you dilute it with the water, you have the fixed volume and then 3 variables so you can calculate the new concentration of the solution. Finally, you want to clean up your workspace when you're done experimenting and ensure that all of your solutions are properly disposed of. In this case, we just had sugar water, so all of our chemicals were A-OK to pour down the sink.